going to look at the design elements of a control system. This is basically just identifying them first, okay, because you are still at the early part. We are not really, there's a lot of things to think about when we want to design a control system, but at the end of the semester, once you've done all the feedback control, the stability, you will begin to look deeper into how to design control systems, considering the type of controllers and considering the instruments that you're going to use. So now there are 4 possible objectives when we want to control something. And they can be, when you want to design a control system, it can serve more than one purpose. So it can be to ensure the stability of the process. This is very, very important. When we want to operate a process, it has to be stable, because once it goes unstable, you can have runaway process, such as if it's an exothermic reactor, it can run away, temperature can get higher and higher, and the reactor can go into a meltdown, or things can explode. So ensuring the stability, ensuring safety, that is ultimately very important. Now, in operating a process, there's always also issues of other variables disturbing the processes. So we want to suppress the influence of external disturbances. So anything that can cause the operating variable to go away from the set point, from the value that we want it to be, that is suppressing the external disturbances. Or we can also optimize the economic performance of a plant. To do this, you will need a model, and you're doing this in the second case study. You're looking at how to develop a dynamic model of a plant, of a process first, and if it's a plant, then it's even more complicated. Or we can combine all these things. So we have to think of what is the purpose of the control system first. Now, let's say we have a heated tank. This is where we have a heated tank, we have flow in, flow out, and we are heating this using saturated steam. Okay, so if you want, can you go to Jamboard? We used this Jamboard in the last class. Okay. So if you look at the previous class Jamboard, you can go to, let me open the Jamboard. Do you have the link? Please go to page 9.
Prof, can you share the link? Because I forgot to code. Okay, thank you.
You gotta share. Okay. So go to Jamboard. Now you see the heated tank system, right? Page 9. Okay, go to page 9. I reserved the earlier ones for your cluster group you're teaching. So if you go to page 9, now can all of you please label the diagram first? Okay, don't use sticky notes because it will cover everything. You can use the text. Okay, so you can use the text and just label whatever variable. Okay, like that. Boleh tak? Okay, I'm going to give you about 30 seconds. Jangan alih-alih, don't move my diagram. Use the text. Okay, click at the text. You can see the cursor, right? Okay, click at the text and then label this. What do you want to label it as? When you label, think also about, is it an input variable or an output variable? So you can fill in the input variable and output variable boxes once you have labeled the diagram. Okay. So, and control objective, what do you think we have to control? Okay. What are the control objectives? If you want to work on the control objectives, that's also fine. Okay. But please label somebody, you can label this. Okay, we have 25 people in here. Please label, and then please also look at the control objectives. Okay, I'm going to keep quiet and give you about 1 minute to fill this in. Don't say water in. We don't know it's water. Okay, H, very good. FITI. I didn't tell you it's water. It's just a heated tank. It can be something. It can be anything. Okay, control valve is okay, but then control valve is not your your variable. Please label the out. You can label the all the other variables. Okay, FST. Where is FST? What is FST? FOTO. Okay, good. Control objective. Somebody can write at the control objective and label what are the input and output variables, please. There's 25 of you. It's okay if you make a mistake because nobody know who you are other than those animals at the top there. Okay. So try, participate. Go ahead and try. Okay. You want to control the flow rate? Are you sure? It's a possibility. Which flow rate? When you want to say you want to control flow rate, which flow rate? There's a lot of flow rates there. Alamak, apa benda tu? What line is this? Anti-ambient, okay. Betul lah you all ni. Let me erase this. Nasib baik dah gambar saya dia tak kena padam. Okay. It's okay now. Control outlet temperature, yes. Now, when you say you want to control flow, that's also a possibility because there's a lot of flow rates there. Yeah. But you have to be sure why you want to do it. Control temperature of liquid, the liquid. Which liquid? Ini kata which liquid. If you want to say liquid, which liquid? So yang ini control the outlet temperature. Okay. So at least we know it's the outlet temperature. What else you want to control? Control the height of the liquid in the tank. Yes. Okay. Tarik sikit. Yes. Yes. Make it longer. Make it longer. Okay. Keep the volume at the desired of liquid at the desired value. That's also possible. Okay, tapi it's the same lah as control the height of the liquid in the tank. Yeah. Okay, output variable lagi. Any other output variable? T0, F0, input TI, FI. Okay, yani when you say saturated steam, what about the saturated steam? What's the input variable associated with the saturated steam? This has to be clearer. Okay, ambient temperature is okay. Yes, that is acceptable because we know it's the ambient temperature. So the saturated steam, it has to be refined. What about the saturated steam? Yeah. So if you say it's FST, then put FST lah. You cannot put just saturated steam. Okay, you want to add PST, the pressure of steam. So pressure of steam, should it be an input or output variable? Okay, then FST, you should put flow of steam. Alamak, don't move the diagram. Okay, flow of saturated steam into the tank. Okay, very good. Can we stop now? Alamak, kenapa FST tu dah hilang? Where is your FST? Now, you all put in FST, PST, TST ni. You want to put there or what? Do you think you want to put it there? Okay, I'm giving you about 15 seconds more. Please don't move the diagram. Ni yang benda ni. Okay. Okay, done Okay, now, please stop doing anything else So I want to ask you something so control the height of the liquid in the tank. Yes, that is logical. The liquid in the tank, if the flow in is not equal to the flow out. Now, if you're told there's a pump at the flow in and it is set to be the same as flow out, then flow in can be equal to flow out. Okay, so in that case, you don't have to control the level. But nothing is said about flow in or flow out, and we don't know whether it's equal. So most likely it can vary. So of course, yes, H, the level, we need to control it because we do not want the tank to go dry or to overflow. Okay, so that is good. Control the temperature of the system. You need to be more specific. If it's temperature of the system, what is the system? Because the whole thing is this is the system. Okay. Do you mean is the steam coil is also part of the system? The stirrer is also part of the system. Yeah. So when you say it's a system, it's better for you to specify what it is. You can say the liquid in the tank, or the flow out. Control the outlet flow temperature. Okay. So now there's an embedded assumption if you say that. The assumption is that because this is a stirred tank, we assume that the temperature or the mixture inside the tank is all well mixed. Yeah. So there's no temperature variation in the tank. So since there's no temperature variation in the tank, the flow of the liquid coming out of the tank would have the same temperature as the liquid in the tank. So T0 will be the same as, TO will be the same as T in the tank. Okay, so that is an assumption that you will have to clear out first, because in certain cases, if the stirrer is not that efficient, there may be temperature variation and the temperature out may not be the same as the temperature inside the tank. So now in terms of the input variable, TI, FI, okay, very good. Ambient temperature, yes. Temperature of saturated steam, yes. So output variable T0, yes. F0, yes. What is FC? I cannot see FC anywhere. Am I missing something? Ada tak? Okay, kejap Pressure of the steam, volume of liquid. Yes, volume of liquid or the height of the liquid in the tank. Now, the tank is cylindrical, so the cross-section area is the same. So when the cross-section area is the same throughout, then you can say that when you control the level will be, there's a straightforward correlation between the level and the volume in the tank. Okay. Now, if the tank is spherical, then it's not straightforward. Okay, but it is still related to the it is still related to the level of the tank. Yeah, more related to the radius lah. The radius if it's spherical. Okay, now you can label this. That's okay. Flow of steam, pressure of steam, and temperature of steam. Now I want to ask you, if you remember from your thermodynamics class, for saturated steam, is the temperature and the pressure related, or are they independent of each other? Siapa boleh jawab? Can you put this? Can you write this on in the chat area? For saturated steam, is the temperature and pressure independent of each other? Are they related? Are they related, or are they? They can be anything. Okay, Siva, you see related, eh? Lagi, other people? Is it related or not related? Anybody else? Do you still remember your thermo class? Related. Yes. Okay, very good, eh? It is related. So if you specify pressure, you don't have to specify temperature because you can look it up on the steam table. Betul tak? If you specify temperature, you can look up the pressure. So you only need to specify one, because they are not independent from one another. Now, in this class, you really have to remember all your chemical engineering classes. If we look at a certain process. Now, would this be an output variable or input variable? The pressure of steam.
Input.
Input or output? Input or output?
Input.
Yes, it should be an input. Alamak, what did I do? I don't want to annotate. So yang ini patutnya dekat sini, Okay. Now your steam temperature you don't have to put it there because it will follow. Or if you put steam temperature, and then don't put steam pressure, So it's either one, only one of them. Okay, now, so control objective is we want to control the height of the liquid in the tank and the temperature. Yeah. So you have two variables, two output variables that you can control now, So very good. You have managed to define that. Now, let us look at this. Yeah. So it's either the volume or the height. Yeah. In this case, I've listed volume, but it can also be the height. Okay. So it doesn't matter. If you type volume, then then just use volume. If you want to type height, then use the height. So actually after this, I'm shifting to height. Yeah, it's easier to see actually. Okay, now how to control we have selected what to control. Now how to control? Okay, you go to page 10 and try and work it out. How can we control? Which means that how can we now, given that we have selected the control variable, what should we measure? What should we manipulate? Okay, so go to page 10 on Jamboard, on the next page. Boleh? And please do it. So everybody pergi tengok Jamboard, page 10. What is the control variable? If you want to control level, what is the control variable? If you want to control temperature, what is the variable that you want to not control, what is the variable you want to manipulate? Sorry, I'm using the wrong terminology. By the way, everybody please try. you can just use the label pun boleh je. You can just use the label. If it's H, just put H. If it's FITI, then put FITI. Yeah. So you can label it now. Let me help label it so that you can just use the labels. So tadi you all guna, actually I use F and T. Okay. So just use the label, eh? Okay. What are the disturbances? Now, what do you want to manipulate for the level? What can we manipulate? Okay, you want to manipulate flow of the outlet stream. That is valid. Very good. What is the measured variable? Measured variable and control variable. It's feedback kan? So it's the same lah. Okay, very good Height of water. Not water, alamak. Don't use water We don't know what the liquid is. So just say height of liquid in the tank. Don't use water. Yeah. By the way, there's a lot of heated tanks in industry. Even in the palm oil industry, they need to heat the oil. Otherwise, the fats can become solidified. That will be a nightmare. So they have heating in the tanks. So it may not be water. Don't put water. Okay? Don't put water. Don't put water. Please don't put water. You have to edit. Okay, sekejap. Let me edit lah. Alah. Okay, edit. Okay. Ini tak boleh dah. Okay, anyway, let me use my pen then. Alah, need to overwrite. Sekejap, I need to take my pen. Okay, height of liquid in the tank. You can use H. Since we use H, you can use H. You don't have to type everything in full. So manipulated variable, just now you choose FI ke FO. It can be FI, it can be FO. Both can be the manipulated variable. But it depends on which one you choose. The other one will be the disturbance. Okay. What is the disturbance for the temperature control system? E ambient. Yes, very good. Yang ni I don't know how the pressure drop in the tank can be a disturbance. Pressure drop in the steam pressure, yes. If the steam pressure fluctuates, then it will be a disturbance. Okay, so it's not pressure drop in the tank. Okay, very good. So ini height, and this one is also height of the liquid in the tank. And manipulated variable, it can, if you choose flow rate F of the outlet, then the disturbance is Fi. Okay, or you can also switch it around. If you choose this as a manipulated variable, this will not be the disturbance, unless there's a back pressure. Okay, that will be a disturbance. Okay, very good. Let us return to the slides. I need to do this quicker because you need to do your peer teaching. Okay, now, next page. Now, once you want to classify, we have classified just now the manipulated variable. Remember, the manipulated variable, do not mix it up with control variable. The manipulated variable is a variable where we can adjust. That's why usually the manipulated variable in chemical processes is where the valve is, the control valve is. The disturbances, are the input variables that we cannot manipulate. There's no valves, there's no way to manipulate the input variable. So this becomes a disturbance, because if it comes into the system, if it changes, then it will affect the system. Okay, it will affect our control variable. Output variables, these are things coming out, variables coming out from the system. So it can be measured or not measured. If it's measured, then we know the value. If it's not measured, then we don't have any information. Okay, so input variables, very good. You've managed to label most of it. Now, if F has a pump and we can determine the value of F, then this become an output variable. Yeah. Okay, sorry, this become an input variable, not an output variable. So there can be cases where things can change. So you have to think about it. So output variables, if there's no pump, if there's nothing controlling the flow, there's nothing manipulating the flow, then output variable is F, the level in the tank or the volume of liquid in the tank, and the temperature out. Okay, so this is how you can imagine it. Manipulated variables, input variables can be manipulated or they can be not manipulated. Okay, so they can be disturbances. Some of the disturbances can be measured, some of them may not be measured. Usually important disturbances will be measured, yeah, but we may not do anything about it, just know the value. So output variables can also be measured variables or unmeasured variables, and we may control some of the output variables. Okay, so to select the measurements, of course, we need to know what is the control objective. If it's a feedback control system, we know that the measured variable will be the same as the control variable, because we want, once we control something, we want to see whether it has reached the set point or it is at the set point of the value that we desire it to be. So that is why we need to measure the control variable. Okay, so for if it is feed forward, then it's what we normally measure is the disturbance. Okay, we will have to measure one of the disturbances. So temperature, since we want to control temperature, we can measure it with a thermocouple or an RTD, depending on the kind of process or the kind of liquid that we have. What in terms of the value, the volume or the height, we can control either one, and we can measure it using a differential pressure cell. Okay, we measure the pressure at the top, we measure the pressure at the bottom, and based on the differential pressure, we calculate the level. Okay, so what next? Now, which variable we select as manipulated variable for each of the control variable? Now we have done that just now on, we can also, now for the two, now go to page 11 of the Jamboard, because for the two options, you have two options for the level. If you go to Jamboard on page 11, now, to control level, this is where you have to draw by hand. If it's it can be ugly, it doesn't matter. Let's say you want to control level. What now you have identified just now, to control level, you want to manipulate the outlet flow rate. Tahu tak? Yeah, you want to manipulate the outlet flow rate. Now, what is the other way to control level?
Control the inlet flow rate.
Not control, you manipulate. Okay, manipulate, very good. You manipulate the inlet flow rate, not control. Level is still the variable be controlled. So let me draw it. I'm not sure if it will turn out lovely, but so what? So you can control, you can put the control valve here, yeah, and you control level. So alamak. So you have flow control, flow transmitter, and then flow control, and then sinilah, yeah. Or the other way, you manipulate this. you measure this, any flow transmitter, and then you have a flow controller, and then this is being manipulated. Okay, so there's different ways. It depends on the condition of the process. When we get to plant-wide control, then you will see how to decide whether we should decide to take this stream or this stream. Okay, so we have not got to that part yet. Yeah. Okay, now let's look back at the slide. Okay, now once you have selected the manipulated variable, so this is if we select the outlet flow, then whatever the level that we measure, yeah, we will have to compare it with the controller. Yeah, we compare it with the set point. Sorry, compare it with the set point, and then the difference goes into the controller, and the controller will decide whether the valve opening is sufficient or not. Okay, all the others doesn't matter. Whatever disturbance that comes in, the level sensor or the transmitter will detect it and then will give the information to the controller. So this is the F as the manipulated variable. Now, if it's the temperature control system, okay, you can since this is we have this valve, the controller can also manipulate either Fi or the steam flow rate. Okay, so just like the level control system, there's a choice. Okay, of course, the controller can also manipulate the steam flow rate, but the flow rate coming in can also be manipulated. So it's our choice. Okay, maybe there's something with the steam flow rate that cause it not to be suitable to be manipulated. So in this case, we manipulate the flow rate in. Okay, that is also possible. Okay, so for feedback control system, we measure the control variable. Yeah, we measure the control variable, and the controller will decide what the manipulated variable's value should be. Okay, normally the valve opening is manipulated, and then it will go into the process. The thing is, the nice thing about feedback control is that whatever disturbance that comes in, everything gets corrected, but not immediately, because there will be, the disturbance would have already entered the system. Okay. Now for feedback control system, for the temperature, so this is if we manipulate the steam flow rate. Yeah. Now there's a lot of things that we actually have to decide. If we don't have the information, we are actually assuming a lot of things. Yeah. So in this case, we are directly manipulating the steam. And so if there's any, Fi is not fluctuating, it's constant. So that's good. So we don't have to manipulate it. It's already fixed and constant. So manipulating the steam flow rate would be sufficient. Okay. Now, problem in controlling the temperature is that if the response, the temperature is known for slow response, because the heat has to be dissipated in the liquid, in the liquid volume. So if we need to keep the temperature at the set point as much as possible, we don't want the temperature to go off from the set point for a long time. What should we do? So if you go to Jamboard on page 12, okay, look at Jamboard on page 12. Okay, so we can use feed forward. So feed forward control of temperature, that means we are now trying to prevent the temperature from fluctuating because of disturbances. And we need to decide which input variable to measure. Okay, so remember, feed forward, the definition is you measure the input and then you manipulate the manipulated variable. Okay, Now, any suggestions which one should we measure? What do you think we should measure from the input variables? Ada suggestion tak? Just type the variables here inside the box. Yeah. What should be measured? What should be manipulated? Let's say we want to have feed-forward control of T. Yeah. This is T. Yeah. T is the temperature inside the tank and the temperature of the outlet. Any pairing that you suggest? Use the text, use the text part. Pakai text ni. Okay, you want to manipulate steam flow rate. So what is your measured variable? Measure T. That is feedback. If you want to measure T, then that is feedback. This is feedback. Tak boleh, tak boleh. We want to have feed-forward control. Yeah. So this is not feed-forward. Measure T and manipulate FST is correct if it's feedback. Now we want feed-forward control. For feed-forward, okay, measure TI. Okay, that is fine. Measure TI is fine. Manipulate FST. Okay, this is also the same. Measure TI, manipulate FST. Others? Others, what can be measured to manipulate and what can be manipulated? Any other suggestions on the measurement other than TI? Measure TI, manipulate FI. That's also possible. Other than that, measure FI, manipulate. What do you want to manipulate if you measure FI? That is correct. FI is an input variable, so that can be classified as feed forward. But what do you want to manipulate? The definition of feed forward is the measured variable must be one of the disturbances, which is it's one of the input variables. Okay, but there's no rule on the manipulated variable. As long as the manipulated variable can be manipulated to have an impact on the control variable. Measure FI, manipulate FST. Okay, that's also fine. Anything else? Measure TI, T cannot. T is an output variable. So that would be a combination of feed forward and feedback. Okay, now we are looking at feed forward only. Okay, I need to move on because we are going out of time. Okay, but I hope you get the idea. Any of the input, if you measure any of the input, you can manipulate FST or whatever that is suitable. So this is all valid. What you have given is all valid. Well done. I hope everybody can understand this. You have done well. You have shown that you understand the type of variables and also feedback and feed-forward control. Now, I ask you to do it because I want to see if you can understand it. If I see you having some misconception, like you were saying that you want to measure T instead of TI, or maybe that's a typo, I don't know. But then I can give you feedback so that you can correct your understanding. Okay? So please participate. We don't, as you can see, we don't know who wrote what. Yeah, so it's okay to be wrong. Don't be shy. So feed-forward control, these are direct measurements of disturbances to adjust the manipulated variable. Now, feed-forward control by itself is not sufficient. Usually, we would measure the disturbance or the input variable that always change. If something always fluctuate, then it will mess up the system. So maybe it's worth it to put an instrument there, a sensor, so that we can prevent the delay in taking action. Okay, so you can have a combination of feed forward and feedback control. This is normally what is done. So you said this just now. measure TI, and manipulate the FST. This is FI is constant. You can also measure FI and TI if FI is not constant. So measure FI and TI and then put it into the feed-forward controller. Now, inferential control if something cannot be measured directly. In the case of the the heated tank system, nothing is mysterious. We can have the sensors. But usually, commonly in the chemical industry, we use, it's always the product quality that is problematic, such as product composition. Because product composition is normally measured using a gas chromatograph. And if you remember from your analytical chemistry class, a gas chromatograph will take some time for the sample to go in through the capillary tube before it's being separated, before we know what is the composition. So an online GC is very expensive and usually it will cause a lot of time delay. So in the end, some people just take sample and then do it several times in a day. So what is done now is that we come up with an estimator in the form of equations. It can be first principle models or it can be black box models. So with the advancement in computing, we can use this to estimate. We can use models to estimate the value of the control variable and then use this to this information to manipulate whatever the manipulated variables are. So we